Hello, my students. What I would like to do is to walk us through an example of a precipitation stoichiometry problem. This is a truly an AP level problem with what I'd like to additionally ask us to do given the situation. The problem simply asks what volume of 0.1 molar sodium phosphate solution is required to precipitate all the lead 2 ions from 150 milliliters, and we need to be given a concentration, and I had made an error when I typed up this problem, but if we're told we have a 0.750 molar lead 2 nitrate solution. Well, this is going to involve some kind of stoichiometry, so we first need our balanced chemical reaction. We are reacting sodium phosphate. First, what enters my mind is a solution. I know that all sodium compounds are soluble in water. We are reacting that with a solution of lead 2 nitrate. Now, usually lead 2 compounds are insoluble. However, we know when paired with nitrate, that makes it soluble. This is a double placement reaction where we will form sodium nitrate, which will be soluble because of the sodium and nitrate composition, and lead 2 phosphate as our precipitate following the solubility rules. Balancing this equation, we would need a 6, a 3, and a 2. The question is, what volume? And because we're given milliliters of the lead 2 nitrate solution, I would go ahead and solve for milliliters of this solution, and it's 0.1 molar. So really, to address this question, it's basic stoichiometry. So we're going to start with our given. Why don't we go ahead and begin with 150 milliliters of the lead 2 nitrate solution. To be able to use molarity to get moles, we need to convert out of milliliters into liters. And this is of our lead 2 nitrate solution. And then using our molarity, for every 1 liter of the lead 2 nitrate solution, there's 0.750 moles of the PbNO3 2. Now we can go to our mole ratio. There's 3 moles of PbNO3 2 for every 2 moles of sodium phosphate. We're asked for volume, so now we can use the molarity of the sodium phosphate, and here it's 0.100 moles of sodium phosphate for every 1 liter of our solution, and if we're getting milliliters, we know that 1 liter is 1,000 milliliters of the sodium phosphate solution. So doing this math, we get 747 milliliters of the sodium phosphate solution would be required to precipitate all of these lead ions. Well, a good AP additional question would come in the form of asking us for the concentration of lead ion and the concentration of nitrate ion after the reaction has proceeded. So we have to have a good idea of what is going on to drive this reaction. If we would develop the ionic and the net ionic equation, the driving force is the finding of the phosphate and the lead 2 ions for each other to create the Pb3PO4 precipitate. This compound is the source of the lead plus 2 ion and the nitrate ion. This compound is the source of the sodium ion and the phosphate ion. Now, all the phosphate that is given here will be claimed, all the lead that is given from here will be claimed by the phosphate and precipitated. So at this point in our course, we would say, after this reaction, because this is not a living reactant, everything completely reacts. So all of this lead will be bound to the phosphate. So after the reaction, we no longer have any lead plus 2 ion. Concentration is 0. But the nitrate is a spectator. Yes, it goes to quote-unquote form sodium nitrate, but if we would do the ionic, we see to the net ionic that the nitrate is simply a spectator. So whatever amount of nitrate is given from here is the same amount that will be left after the reaction is over. So if we then take the 150 milliliters of PbNO3 as our given, get ourselves to liters so that we can utilize molarity, and for every 1 liter of the PbNO3 for our concentration, it's 0.750 moles of PbNO3. But I am trying to find what is the concentration of the nitrate ion that remains. Brackets mean molarity. So I need to know, as the reaction has proceeded, how many moles of nitrate do I have in the entire volume of the solution. So I need to then get myself for moles of lead 2 nitrate, 2 moles of nitrate. So I just interpret the formula. So what I get here after I do my math, I get 0.225 moles of nitrate. Just want to double check that. I'm just in a habit that I always do each of my math. Okay, perfect. So that is the amount of moles that is given by the reactant and will be remaining as the spectator. However, to get concentration, I am adding volume. I am adding volume. I want to know the concentration once these have been added together. So, I assume that the total volume does not change tremendously because of the presence of the precipitate and so on. So, what I need to do is add up my mils, and with sig figs, I get 897 mils. Then converting to liters, it would be 0.897 liters, which gives me a molarity of 0.251 molar nitrate in my solution.